Hello, good morning, students, dear friends. Welcome to our electrical circuits. Let me start an important subject today is superposition theorem. In previous classes, we have covered the basic Ohm's law and Kirchhoff's current law, Kirchhoff's voltage law, stall delta conversation used to solve our complex networks. Somewhat we are succeeded to know electrical characteristics of any branch based on our previous knowledges. Now, if the network consists of more than one source, then how to solve easily? Already we have drawn so many equations by applying KCL and KVL in a networks, the branch current method, loop analysis and nodal analysis. Here is a very easy understanding theorem, that is a superposition theorem. Let us start this one. To the objects, on completion of this period, you would be able to know the statement of superposition theorem, the explanation of how the superposition theorem works, and its application of superposition theorem in our electrical network fields. Now, known to unknown, what we have seen in previous classes. Ohm's law provides the fundamental tool for solving electrical networks, but it has some limitations. It obeys linearity. It will apply for only linear networks. It cannot be applied to circuits where more than one source is acting simultaneously in the circuit. In such cases, we can apply our basic Kirchhoff current law and Kirchhoff voltage law. Even while applying KCL and KVL to the networks, the number of simultaneous equations to be handled becomes more when the network is complicated and increased. As we have seen, this number of equations has increased when network branches increases. That's why we have solved these problems by using Cramer's rule in matrix. That bottlenecks can be reduced with help of the latest important theorem, that is superposition theorem. What is the basic concept here one? Let me tell you what is a interconnected system in power engineering. As you know that, before going to the topic, how the sources exist in our electrical fields more than one types. Let us assume in our power grid, as you see here, this is a power grid center. We can say that is a smart grid. Smart grid, automatical operation takes place in every place with smart. What about the electrical energy generated from thermal power station, wind power station, hydro power station and solar power station, that is a non-conventional energy source, and as well as sometimes we can use this is known as the piezoelectric energy station, whereas the physical property changes on some crystallized materials, there is a possible to induce an EMF in the circuit. That is also we can connect it. And diesel power stations, different stations, all are interconnected to the common point, all are interconnected to the common points. That is a power grid. As we know that in summer season we can generate thermal power station as a base load power plant, and whereas a hydro power station is a minor power plant where it can generate only at the time of the peak hours, peak power plants. If load demand increases further on our network system, then we can opt for hydro power station in summer season. Whereas in case of the rainy season, we can choose hydropower plant as a base power station. At that condition, we can use thermal power station as a peak power plant. As per our convenience, as per our available fossil fuels and water available in the dam, we can manage optimally as per requirement. So, but as a consumer, you can see here, as a consumer, a domestic customer, we not bothered whether you are going to generate in thermal power station, hydro power station or any other non-conventional energy sources. I require electrical energy 24 into 7 days. That means I require the supply, reliable supply is required and quality power supply is required. I don't bother about which type of the generation are taking place. Now, nowadays, the most of the consumers also diverted dual power supplies, where their top roofs they will provide it a solar panels, they will connect it to UPS in their homes. Daytime they will receive solar energy simultaneously with some amount of the energy from DISCOM people. During the night time, whatever the stored, the energy can be used for normal applications. Thereby, the total cost payable to the DISCOM people is reduced. If power failures from DISCOM or GENCO or TRANSCO, at that condition they will use a second power from UPS as a solar panels. Here we are using the two energy sources. One, we can say that one is the solar panel power, another is the DISCOM power. Then how much energy is taking from solar energy and a DISCOM people to our normal existing loads, whether it may be tube lights, whether it may be TV, fridge and etc. in daily life. Similarly, in the network also consists of more than one source. As we calculated few problems, whether the sources may be dependent source or independent source, whether it is a voltage source, whether it is a current source in the circuit. At a particular branch, I want to know that what is the current, what is the power loss at that element, can be simplified with help of superposition theorem. What do you mean with the superposition theorem? Let us see that. So, normally it states that in any linear bilateral network, what do you mean by the linear? Linear means it obeys the Ohm's law. V is equal to I into R, not square of the terms present in the equation. Linear and bilateral, that means the either of the direction current flows, the property of the material may not change, property of the element does not change. That is a bilateral two-way tropic, the road in which two ways, the bilateral network. In any linear bilateral network having two or more voltage sources, the current through any branch is the algebraic sum of the currents produced by each source acting alone at a time when all other sources are replaced by their internal resistance. This is known as the simple superposition theorem. Let us see it. It states that superposition theorem states that in any linear active bilateral network having more than one source, the response across any element is the sum of the responses obtained from each source considered separately, and all other sources are replaced by their internal resistance. The superposition theorem is used to solve the network where two or more sources are present and connected in the circuit. Have you understood? Let me tell you simple circuit. Okay? Now, for example, take the one example, known example. Suppose here is yourself. Now, you have parents, your father and your mother. Now you are going to the college. They will give you a pocket money to you for every week or month, some amount for bus fares or auto fares. Now, how much amount given by your parents I want to know. Average amount given by your parents. I want to know that how much the amount they will arrange every month approximately. Sometimes you can take the amount from your mummy without knowing your father observation. Sometimes you can take the amount from your father in absence of your mother. Then how much amount you have collected during that month? Here your father is a one source. Your father is a one source. maybe this is a voltage source, then your mother is another source, maybe current source. You are the one element, that is the resistive element. Then how much impact from your both mother and father? He may give the 100 rupees in a week. In addition to, you have taken some amount from your mother for purchasing of something, pen and notebooks. In second week itself, third week and fourth week, I want to know that how much amount you have collected, taken from your parents. This is a situation. I want to find that what is the amount collected in a particular time from two sources. That is the superposition theorem. How to calculate? Now, so in this case, we are assuming that now suppose first of all you calculate whatever the amount collected from your father. That means in first week how much you are taking. For example, you taken the 100 rupees. In second week how much you have taken? Only 75 rupees. A third week you have how much taken? 200 rupees. And fourth week how much taken you have taken? So 300 rupees. This is the amount collected from your father alone. Now sum up this amount. Next, now you consider your mother amount. Then in first week how much you have taken? You taken only 20 rupees first week. In second week you taken the 85 rupees. And third week you taken nil amount. You have not taken any amount from your mother. And fourth week you have taken only 106 rupees. Then sum it, you are going to get some amount. Now how much amount you have in that month? That is total amount summed from your father amount and your mother amount. This amount plus this amount. For example, your father amount is already added. You are going to, let us assume this may be 505 rupees. Your mother amount you have taken, for example, it may be 165 rupees. The total amount is the 505 plus 165. How much? That is equal to 670 rupees amount you have collected from your father and mother for your pocket money. Here your father acting as a one source, whether we are assuming as a voltage source. Now your mother acting as a current source. She has also tried to give some little amount to you without knowing to your father. Now total amount is sum of the amount you have taken from your parents. That amount 767, what is the cost? 670 amount is the total amount you have taken from your parents. Similarly, in our networks also, just like assume that one source at a time, remaining source kept aside by assuming that if that source is voltage source, simply short with internal resistance of that source. If there is no internal ideal case, then you simply short it. So we know that there is no possible to get ideal voltage source. Every source has its own internal resistance. Then simply at a time you assume that one source is acting and remaining sources, if it consists voltage sources, simply replace that voltage source with its internal resistance, and if current source presents, then simply open the terminals, because we know that the current source has the infinity resistance, and whereas the voltage source has in series very less resistance. So, assuming that condition, for example, if two sources presents, one is a current source, another is a voltage source, while calculating your voltage source, then remaining current source in the circuit, simply open it, then calculate what is the values in a specified element with help of basic Ohm's law, series parallel circuits. After knowing this one, then once again recover circuit, then in this case, then short or connect, remove the voltage source, and in place you connect the battery which is removed as its internal resistance replaced with that internal resistance. Then apply the current source. Now find the value in a specified what you are calculated in previously with the help of voltage source. At that element, what is the impact of this current source values separately. Then the value which is we are going to get it, that value plus already you got it with the help of the voltage source, sum it, whether add or subtract based on the plus or minus. That is a final value we are going to get it. Okay, so don't confuse it. Let us see in step by step. Okay, so what is the superposition theorem? The superposition theorem, once again, superposition theorem states that in any linear active bilateral network having more than one source, the response across any element is the sum of the responses obtained from each source considered separately, and all other sources are replaced by their internal resistances. Okay. Now, this superposition theorem is used to solve the networks where two or more sources are present and connected. Here we assumed your mother and father. Sometimes there is may be possibility your uncle or aunt, you may collect the amount, your sister and brother. Then I want to find amount on your packet in a during or some period, calculated separately how much amount taken from your parent, that is a father, mother, your uncle, your aunt, your sister, your brother. Okay. So, at a time you are considered add that amount, remaining you replace with their internal resistances. Okay. Now, what is the salient points in a superposition theorem? Now, the internal resistance of an ideal voltage source is 0. It should be minimum. So, you are going to just keep it, if the internal resistance is 0, then simply short the two terminals. The internal resistance of the ideal current source is infinity, then open the two terminals in the given network. If the given source are non-ideal condition, practical one, then replace with their own internal resistances. It is only applicable to the circuit which is valid for the Ohm's law. What is the Ohm's law? It obeys linearity. So, V is proportional to current, I proportional to voltage. At constant temperature, the current in a closed circuit is directly proportional to the applied voltage. If current voltage increases, current increases. It increases, that increases. Linearity. So, we can apply the superposition theorem. Friends, you have to remember this. The superposition law can be applied only for linear circuits. Let us explain one by one in details. Let us take one circuit, simple circuit, where it has two sources, V1 and V2. Now, in this case, you assume that one is your father and another is your elder brother. Now, you are the one person in between. You take the one element, resistive element, always you are consuming during the student. You are not earning any amount, but whatever you need, you can collect from your father and your elder brother who is doing job. Now, let us see it. Explanation of superposition theorem. It can be stated as if a number of voltage and current sources, okay, so your sister or brother, number of sources, are acting in a linear network, the resultant current in any branch is the algebraic sum of all the currents that would be produced in it. When each source acts alone while all other independent sources are replaced by their internal resistance. Don't panic, you can see simple. You take this circuit. What is this? Now, this is a V1 source, this is a V2 source, two sources connected. Now, there is a one resistance, there is another resistance, here is another resistance. Let me know what is the current in this circuit R3. Here R3 you are going to assume yourself. Okay. Now, I want to know that what is the current, resultant total current across through R3 due to the influence of V1, influence of V2. As you know that, so here what is the R2, what is the R1 and R2 also we can found. But here intention is I want to know what is the amount you are collected from your father and your brother. Okay. So, I want to know that. What to do? Let us do one by one. Now, so as per law, you have to consider only one source at a time. At that condition, remaining source should be open or closed based on their internal resistance. Okay, that should be remembered. Now, do it this one. Now, what has happened here? Here, this is given circuit. Here V1 is due to the V1 the current is flowing here, due to the V2 current is flowing here. Don't apply the loop analysis here. Okay. So, I want to know that this one. In this case, first case, I want to, what is this voltage source? So, there is no internal resistance is given, then simply this is a voltage source. So, once voltage source is given, simply short it. Here I short it. Then at that condition, just I removed this voltage source and shorted these two lines. Now, what will happen? You can see here. Simply it appears as a R2 and R3 connected in parallel. Just you observe it. And R2 and R3 connected in parallel, and at the same time we can represent it as a currents. The current which is flowing through R1 is equal to I1 dash. Just represented that indication I1 dash, single dash represent the, we are observing, we are taking supply only V1 source with V1. So, the current which is flowing through the R1 is represented as the I1 dash, you can see here. Now, at note, the current is I2 dash is current flowing through the R2 and I3 dash is flowing through the R3. You can observe here. Okay. So, the current here assumed that is equal I1 dash. The current flowing here is the I2 dash, and the current flowing in the circuit is the I3 dash. We are assumed, represented. Okay. Now, what you have observed here, this is the source resistance, and this is this one you are going to calculate, and this is simply nothing but is connected here. Okay. So, just is a simplified circuit. This is equal to R1, this is equal to R2, this is equal to R3. We can take this I1 dash, this is I2 dash, this is I3 dash. This is the nodal. Okay. Simply apply the Ohm's law. Now, what is happened here? R2 and R3 is connected in simple parallel. So, simplify it, we are going to 1. Now, connect the what is the R1. Now, connect the source. What is the one? This is the R1. This is the resultant of R1, R2 parallel with the R3. Okay. Now, both are series. Then we are going to get R1 plus this combination of, you can say the R4. You can say this is called R4. Then R1 plus R4, we are going to get the total resistance in the circuit. Okay. So, that is called RT is equal to R1 plus R4. Now, we know the total resistance, we know the voltage here, just apply the current. What is the current rule? I is equal to V by R, RT, that is the total resistance. Then V is given V1 by RT, we are calculated, this is the capital RT. So, we are going to find that what is the current from the source. Okay. Then the current is coming here, R1 is the same current, we got it I1 dash. Now, we know this I1 dash current. Now, based on the parallel circuit, I want to know that, so I3 dash. Based on the current division formula, I easily calculated I3 dash is equal to total current I1 dash into R2 by R2 plus R3. So, I am going to get the I3 dash current. Okay. That is simple current, you can easily calculate it. So, I know this I3 dash current now. Once I considered with V1. Now, coming to the another source, same you can see here. So, what has happened here? So, what we have seen here, the value of the current flowing in each branch, that is I1 dash, I2 dash and I3 dash is calculated by the following equations. I1 dash, so we know the total current R1 and R2, R3 is connected, we just you calculated equation 1. Okay. R2 dash also we calculated this one, and now, so based on this one, I1 dash minus, that is equal, I1 dash is coming and I2 dash is calculated. So, what is the total current minus, that is I2 dash, we are going to the I3 dash, or we can calculate a simple our current division method. We are very familiar with the simplification of networks. Then, so whatever the you calculate, we calculated that the I2, I3 dash current now in the first case. Okay. Sorry. Now, we calculated, so I1 dash based on our basic knowledge, and I2 dash we calculated, and I3 dash, so we calculate this one. Now, we got it I3 dash current, just keep it at sight. Now, first case, whatever the we are assumed, single source V1 source we are assumed and V2 source is shorted, and we calculated the required value I3 dash in element R3. Okay. Now, in the second case, what we are going to do? So, in this second case, we are going to assume that V2 alone, V1 shorted. Okay. Let us do. Now, in this case, now what we are going to do? So, now activating the voltage source V2 and deactivating the voltage source V1 by short circuiting it, because there is no internal resistance is given. Find the various currents. Similarly, I1 double dash, I2 double dash, I3 double dash flowing in the circuit diagram shown. Similarly, so what here current? Okay. So, in this case we are shorted this one, you can observe here. Then only this is a source activating. Now, what you are observed, and here R1 and R3 is connected in parallel, okay, and it is connected with the series with the R2, simple circuit. So, in this case we are going to calculate, this is a R1 and this is a R3, and here we connected the R2 source, okay. So, this is the current. This is a what we have said, I2 double dash, second source. This is a I3 double dash. This is a I1 double dash. Okay. So, you know that R1 and R3 and this is a R2. Now, we can see here the R1 and R3 is a parallel. Simplify it. So, we are going to get this is the R4 just for example. Now, R4 and R2 connected through our source. Now, both are connected in series. Simply R4 plus R2, we are going to the total resistance RT double dash. Then V2 is a source. Then I want the current. I current is equal V by T. What is the V? The V2. What is the R? This resistance, this is connected in series. Then RT double dash. Then we are going to get what is the current. That current is flowing through the I2 dash in this case. Once I2 dash current is known, based on the current division method, I want to know the I3 current here. Simply apply it. I2 dash into R1 by R1 plus R3. We are going to get this current. Then I got it, I3 double dash. Okay. Now, or we can simply use the KCL also. So, we are going to get similar. So, here you can see that what is the I2 dash. So, I2 dash is equal total V2 by, now here so R1 and R3 is connected in parallel, simplified it and plus R2. Then similarly I1 dash also we calculated. So, that is equal I2 dash R3 by R1 plus R3. Once R2 dash is known, R1 dash known, so we are going to find that I3 dash is equal I2 dash input current minus I1 dash. So, we got it I3 dash also with influence of V2 when V1 is absence. As per the superposition theorem, the value of now, what is the value? So, I1 and I2, I3 is calculated as, now in each element I3 is equal to, now in this case you can see it, I3 that is the current flowing in a R3 element is equal to, so both times the current direction is the same direction, only bottom direction. Then I can say I3 dash plus I3 double dash, both sides we are assumed as a current direction, same direction. So, we adding the current with influence of V1 and V2. So, we are going to get current that is required, that is the amount you are taken from your brother and father. Okay. Now, if I want to know what is the I2 current also, that I2 current you can see it, the I2 dash one direction, and while applying the V2 we are going to opposite direction, that is why I2 dash minus I2 double dash, this current minus this current, then we are going to get the final current I2. Similarly, I1 current also, so I1 dash minus I2 I1 double dash. So, we are going to I1 current. So, these are the currents we calculated in a given elements, whether it is a R1 element and a R2 element and a R3 element. So, this is a one good example. Okay. So, dear students, I think you have understood these values. Okay. Now let us know the steps. Okay. So what are the steps now? So please don't confuse. Similarly, once again I am concluding it, you can see it. Here what we have seen in first case, here what is given? Here is one source is given. This is a one source. Now here connected one resistance, another resistance, here another resistance, another source is given. Okay. Now we taken is a R1, R2, R3 we taken as. We taken is a V1 and V2. The internal resistance we assumed as a 0. Okay. Now we represented the current is here is equal to I1. The current in the circuit is equal to I2. We can say it is a I2. We current we taken is a I3. Okay. From the source I1 current, this is the I2 current, this is the I3 current. So here I want to know that I1 current from V1 source, I2 current from V2 source, whereas the R3 is the sum of the currents. Let us assume. Now by using the superposition theorem, here I am going to calculate the current. What is the I3 current and what is the current of I1 with influence of V2 also, and I2 current with influence of V1. These are the I want to know. For this purpose, I am going to consider as per the superposition theorem superimposed. So superimposed, we calculate separately that imposing two results. We are going to get the final value. Now superimposition purpose, before imposition I require the raw material. First I want to know, first by applying the V1 source and removing the V2 source. Then what we have seen here, this is a source is given. Now first case what we have seen, first I connected only V1 resistance. All networks elements are passive elements are same, but only active element I taken out, because here if the internal resistance is given, suppose R2, so this is called R something capital R is given internal resistance, then I represented here. Here not is given any internal resistance, simply I shorted as per the basic theory. Now here is R1, R2 and R3 and this is V1. Simple circuit. From this circuit I calculated what is the current I1 dash with the help of V1. This is the I2 dash. This is the I3 dash we calculated. Okay students, you calculated this thing. In second case, what we have seen? In second case, what we have seen? Now, in this case, here the second side, this source is applied here, resistance connected here. Here, remove the source now. Now, what is happening? V1 is removed. Here is a R1, this is a R2, this is a R3. Simple, passive elements are same. Now, this is a V2. Now, I want to know that what is the current is. This is called I2 double dash I1. We have taken this, the current is flowing this direction. Let us, whatever the direction you assume it, no problem. I1 double dash and I2, I3 double dash. If you observe carefully, so here what will happen? R1 parallel with R3. Now it is connected with R2. That is the total resistance. Okay. So, based on this simple calculations, I found that, so here I1 dash double dash, I2 double dash and I3 double dash. From previous cases, from this network, here calculated from this one. So, I1 single dash, I2 single dash and I3 single dash also we calculated with this first network. Now, these currents and these currents now add it in the circuit, third case. Okay. Now, in the circuit, what is the current? So, here the I1 dash current is equal to I1 dash minus I1 double dash, because one direction the current taken is the, you can see here what is happened. In the first case I assumed the current this direction. Okay. First case I assumed, so this value in this direction. Okay. Second case I assumed as this direction. So, I1 dash minus I2, whether you are going to the minus or positive irrespective of that one, just you are assumed. If it gets the positive value, your assumption is good. But otherwise, you are going to get the minus value, just change its direction. Nothing will happen. Okay. Now, similarly, we calculate what is the I2 current, that is equal, in this case what is the we are observing, I2 dash minus I2 double dash. Here also one direction, this direction, another direction, this direction. Now, here I3 is equal to I3 single dash plus I3 double dash. Both direction, the current direction, the element is both same direction. So, we know these two all currents. So, we are going to find that I1, I2, I3. That is the currents. If you know the current, so you can easily calculate whatever you required. So, I want the power in P1, in resistance R1 I want to. So, simply I1 whole square R1, I am going to the power, and similarly P2 and P3, and we can energy also E1 and E2 and E3, whatever you required you can easily calculate it if you know the current values in the elements. Okay. So, this is a simple application of supervision learning. Okay. Dear students, what you have observed once again, here is given circuit is this is a given circuit. Okay. So, this is a given circuit. So, in this circuit, here we are assume the two sources on. Suppose 3 sources is given, then you take the 3 times. 4 sources is given 4 times. Whether here given the voltage source or current source, then simply apply the current source and voltage source. Whatever the source, it may be current source or voltage source. If the current source is given, simply open the terminals. For example, here assuming that, so here you are going to for example, okay. Now, I remove this source, here I taken the current source. What is the difference? Now, in this case, simply I difference is that in first case what we have calculated, and in the first case okay, in the first case here what will happen? So, here this circuit is simply, here what will happen? So, this is a source, this is a terminal. Now, this is opened because this is due to the current source is not shorted, it is open. Then what will happen? R1 and R3 simple series, then V1. Then find the what is the current influence of this one, simple circuit. Okay. In second case, what you have seen? Now, second case, here simply this is the voltage source, short it, this R1, this is the R3 and this is the R2, you connect the current source. Then what is the current in this one, influence of this current? So, by the branch current method, you can easily calculate the what is the influence of this one, that is the difference. Okay. So, whether it is given the voltage source and current source, we can easily calculate the required values in the circuit. This is the superposition theorem. Now, let us see steps one by one, how to calculate steps. You have to remember the steps. Okay. Now, steps for solving network by superposition theorem. Considering the circuit diagram A, let us see the various steps to solve the superposition theorem. Dear friends, you may get the bore, but some students are unable to follow. That's why I am giving the step by step methods to solve the problem. Okay, please bear with me. Now, what is the step 1? Here, take only one independent source of voltage or current and deactivate the other sources. First step. Okay, whether here you can take this given network, so deactivate this one, take only one source in first case. In second case, just you take the one source, deactivate this source in this case. If it is internal resistance is given, you keep it, otherwise simply short it. Okay. Now, second step, in the circuit diagram B, you can see this is the B diagram shown above. Consider the source E1 and replace the other source E2 by its internal resistance. If its internal resistance is not given, then it is taken as 0 and the source is shorted as shown in the figure. Okay, that is the step 2. You can see in the figure. What is the step 3? Now, in step 3, if there is a voltage source, then short circuit it, and if there is a current source, then just open it. Okay, as we, if current source, simply open the two terminals, and if voltage source, then simply short if there is no internal resistance given. Okay. Now, step 4. Thus, by activating one source and deactivating the other source, find the current in each branch of the network by applying the simple series parallel circuits methods, that by using the Ohm's law. Taking the above example, find the current I1 dash, I2 dash, I3 dash, already we have calculated. That is the fourth step. Now, what is the fifth step? Now, consider the other source E2 in this case and replace the source E1 by its internal resistance R1. Here, E1 consists of R1 is the internal resistance. So, instead of shorting, we connected the R1 in series with the capital R1 source. You can observe here. Okay. Here, what is happened? So, this given circuit is given. Here, internal resistance R1 is given. So, we replace the voltage source, we taken the, this is the internal resistance. Okay. Now, sixth step, determine the currents in various sections with the help of the E2, the I1 double dash, I2 double dash and I3 double dash, similar what we have seen. Okay, this is a step 6. Now, step 7. Now, to determine the net branch current utilizing the superposition theorem, add the currents obtained from each individual source for each branch, whatever you have calculated with the influence of current. So, that is the I1 dash, so that is I1 single dash and I2 single dash and I3 single dash. Similarly, I1 double dash, I2 double dash and I3 double dash, we calculated influence of E1 and U2. Then simply add the resultant values. If number of sources increases, then I1 triple dash, I2 triple dash and I3 triple dash. Suppose another source, then you take the I1 4 4. Similarly, you go on. Okay, then that is the 7th step. What is the 8th step? If the current obtained by each branch is the same direction, then add them. Simply add it. If it is in the opposite direction, subtract them to obtain the net current in each branch. Okay. So, please remember the direction of the current, what you are assumed in each case. Keep it in mind. That is the 8th step. Now, after getting this one, the actual flow of current in the circuit C, this is the final circuit, will be given by the equations shown below. What is the current? I1 current, I2 current, I3 current, what we have seen previously. Thus, in this way we can solve the superposition theorem. Okay. So, these are the 8 steps you have to follow the problem without any confusing. I think this is all theoretical parts. If in place of R1 is equal some resistance, so for example 2 ohms, R2 is equal 3 ohms, R4 is equal something you are given, you are going to elaborate. You may get the interest also. Let us do one application also. Okay. So, these are the theory part. Now, let us do the application of superposition theorem. This is a theory we learned. Now, we are going to apply this concept on practical problems. Consider one practical circuit. Let us. Applications of superposition theorem. Here, we take the one circuit. The circuit consists of the B1 is a battery 1, has a 28 volts plus minus, and B2, the battery 2, has a 7 volts. Okay, 2 voltage sources is given. Luckily, the internal resistance is not given. You can observe it. Okay, if consists of the 2 sources, EMF batteries. So, you can see the circuit. Okay, now let us apply the superposition theorem for this one. Dear students, just you can see here is a source value is given, here source value is given, and your R1 is equal to 4 ohms and R2 is equal to 1 ohm. Sorry, R1 is taken here, R1 is equal to, what is the value? R1 is equal to 4 ohms and R2 is equal to, taken as a 2 ohms and R3 is given the 1 ohm. Practical values is given. Now, we are going to calculate the current in each branch. Each branch I am going to calculate. Let us apply our what we have learnt. Let us apply superposition theorem to the circuit shown. So, first consider that battery B1 is acting alone in the circuit. So, here, so battery this is taken here shorted, there is no internal resistance is given. Then what you are observed here, 2 ohms and 1 ohm connected in parallel, and these two are connected in series to the R1, simply series parallel circuit. Now, so therefore, other battery B2 is replaced with a short. Now, calculate the values. Total resistance, first you calculate it, then find the total current from the battery B1, calculate it, then find the current in each branch, calculate it. That is the steps. First, calculate the total resistance. I require this current required. That purpose I require the total resistance RT required I want to. So, both are connected in parallel and is connected in series. So, I am going to get the total resistance. Once total resistance known, once total voltage be known, then I want to calculate the total current from the B1, that is equal V by RT. Total is RT1 in first case. Then I am going to get the total current. From the total current, I am going to calculate what is the branch current, what is the branch current. Okay, these are the 3 steps. Now, let us see. Now, in this case, So here B2 is removed, we can calculate with the help of the B1 only. The resistance has seen by the battery as, so what is the value? That is called total resistance is equal 4 plus 2 into 1 by 2 plus 1, that is equal, we are going to get that. So nearly the 4.667 ohms is the total resistance. Now I want the current. Current is equal, I is equal V by R. So V is equal to how much? 28 by the 4.667. Then we are going to get that nearly 6 amperes is the current. This is the current. Okay, 6 amperes current is flowing from the B1 source only at a time now. Okay, so now what is the value? So current supplied by the battery as a, just you take in the voltage by this value 6 amperes. Now in this case, after 6 amperes flowing in the circuit, now calculate the each branch current. Now 6 amperes is flowing. Here the direction of the actual current flows is considered rather a conventional current. That is a conventional, we know that two types of the current directions. One is a electronic direction, another is a conventional direction. Here we assumed that the current is just arbitrarily assume it. Whether it may be correct or wrong, we are going to get the final value. Okay, here we are conventional current we are assuming for the easy understanding purpose. Okay, now what has happened? In this case, we taken the current is coming into the battery. So here you can observe it. The current direction is, instead of current direction this direction, I taken this direction. The current is coming this direction. So what is the current here coming? 6 amperes. Okay, that means the current is flowing this direction and coming this direction. So current is flowing this direction. Just we are assuming it. Okay, so based on this one, 6 amperes is coming. Now I want to know that the current through the various parallel paths can be easily obtained by applying the current division rule. Voltage acting across each branch can also be calculated. So here you can see it, all values are calculated. What is the current? So here, so you can see, so how we are going to get it? Simply, what is there? This is a this is one. Now what is happening? Here is 6 amperes coming current. Okay, from 6 amperes, you are going to get it. This is a, what is the resistance? Now 2 ohms, this one, this is a 1 ohm resistance. So 2:1 ratio, it is a sharing. Then it's a 4 ohms. Now, so 6 by, what is the current division formula? That the total current, I want the current in the circuit, this current. So in this one, I want to know that what is the value? So that is equal to, so I 1 ohm resistor is equal to total current 6 amperes into what is the resistance? 2 ohms divided by 1 plus 2. That is the current division. You know that very well. So what is the value? 6 into 2 divided by 3. 3 ones are 3 twos are. Then 2 twos are 4. That means here 4 amps is coming this direction. Now I want to this current. So what is the current? 6 minus 4, we are going to get this nearly, what is the current? Nearly 2 amps. Now we find that the current through this branch and this branch is known. Now if you know the current, if you know the resistance, what is the drop here? So you can calculate what is the drop. 2 into 2, 4 volts. What is the voltage here? The 4 into 1, the 4 volts. Okay, the 4 volts, 4 volts. Now what is the current here? 6 amperes. 6 into 4 is 24 volts. So 24 plus 4 volts, 28 volts. That is the value is correct. Okay, so such a way that you are calculating this all currents in a branch. We assume this current is coming this direction, this current is this direction, this current is this direction. Just to remember the direction of the current. While with considering the battery 1 considered. Okay. Now coming to the, if B1 is replaced with its internal resistance. Consider the B2 battery 2 we are considering. Now you can see here what you are observed. Simply you are taken the resistance. Here B1 is the internal resistance shorted, and you are going to get it. So replace the battery B1 with the internal resistance, short it, and then you are going to get simply similar to the you calculate the all values. The resistance as seen by this one. What will happen? R1 and R2 are in parallel. What is the total resistance? Simply calculate it. The total this one and this one is a parallel. Now what is the value? 4 into 1 by 4, 4 into 2 8 by 4 plus 2 6. That is the total resistance. That is equal, we are going to 2.33. And with series plus what is the 1 plus 1, we are going to get nearly 2.33. Okay. So this is both are connected, this one and this one connected parallel, and this one connected in source. So this circuit, this is a 1 ohm and this is the 2 ohms, this is the 4 ohms. So this is the 4 to the 8, 8 by 4 plus 2 6. This is the resistance connected in series 1. So we are going to get that is equal, so 2.33 ohms. This is the resistance, total resistance. If you know the total resistance RT, if you know the volt, this one, then what is the current? The current we are assumed is the I is equal to, so what is the volt 7 by what is the 2.33. So we are going to get that the current value, that is equal to nearly 3 amps. So with the help of the B2, we are going to get the current in the circuit is 3 amps. Okay. So 3 amps. Now conventional current, similarly, instead of showing this direction, so just here going to the conventional current, 3 amps is going and 3 amps entering. Now here what is happening? Just here remember this one. Okay. Now 3 amps is coming based on the current division rule. So how much current is flowing in the 2 ohms, how much current is flowing in 4 ohms, just to find it. Then after that you are going to get the all currents in each branch. Okay. Then this the current supplied by the battery is equal this value, and now sum the total values. So what we are observed here, the current, so similarly we taken the 3 amperes is coming here, 3 amperes. Now some of the current is flowing this direction, some of the current flowing this direction. Okay. Here 1 ampere this direction, and here is a 2 ampere similar current. Previously 2 amperes, now 2 amperes, and both are same directions. Previously instead of this one 2 amps, now this also 2 amps. Now what is the current? 2 plus 2, 4 amps in the circuit of the, if we are connected both sources in the circuit. Now here in previous cases the current is coming the 6 amperes. Now the 1 ampere is going this direction. What is the resultant? Well, 5 amperes current this direction. Okay. So similarly here the 3 amps is coming this direction, and previously what is the current going this direction? That may be 6 plus 1, that's the, what is the value? So we are taking this, the current is the 2 ampere, 6, 4 ampere. Okay, 4 amperes is coming. Okay, the 4 is one direction, 3 is the one direction, so 1 ampere. So 1 ampere current is flowing in the R3. Okay, that is the final result. You can see here, don't confuse. Voltage acting across each resistor can also be calculated. Then, so we are going to get first by using first B1 battery, we find the all values, and please find that the current direction also. Please remember the current directions. And in second case, with the help of the V2, we calculated this current directions. Now finally we are going to get what is the this place, this is equal to final circuit. What is that one? So we are going to get, so this is the final circuit. Now you can observe here the current is in this case flowing here 6 amperes, in this case 1 ampere, 6 minus 1, 5 amperes current. Here 4 amps coming here, here is a 3 amps coming this direction. So 4 minus 3, we are going to get this 1 ampere this direction. Here 2 amperes going here, here is a 2 amperes also going here, 2 plus 2, 4 amperes going here. Simply the superimposed. This one imposed, we are going to get the final one. That is known as the superposition theorem. Now you can see the same thing. Okay, so how we are going to calculate the here? The first case we calculate the currents, and the second case we calculate the drop. Once we know the current, once we know the resistance, we are going to calculate the voltage. That is calculated here. What is the voltage drop? What is the voltage drop here? Okay, this is a method of calculating the unknown complex circuits if consist more number of sources, whether it may be voltage sources and current sources. In further classes, you are going to get the dependent sources and independent sources also. Okay, so this is a method to calculate in superposition theorem to know the characteristics of any element. Now, so this is a one circuit we have seen. Okay, so let us one problem we are done. What is the time now? So 1:11. Okay, similarly you can do the remaining problem also. So let us do one problem quickly. So this is the application of problem. So from this one you are going to get it final value. Okay, problem 2. Here I am going to give the concept. Please follow that one. Here what is the using the superposition theorem, find the current flowing through the 5 ohms resistor in the circuit. Where is the 5 ohm? The 5 ohm resistor, yeah, this is the resistance. I want to know that what is the current flowing through the 5 ohm resistor with the influence of 30 volts voltage source and 6 amperes current source. Here 2 sources is given. One is a voltage source and is a current source. One is a father and is a mother. Now 5 ohms is a yourself. Now I want to know that what is the total current with the influence of your father and mother. Okay, let us do it. Simple. You apply the source at a time 1% only. Then find the what are the value in 5 ohm. Then find the your mother. Find the values. After that you summarize what both. Then you are going to the answer. Okay. Now do it. There are the 2 sources. One is voltage source and other is the current source. And so we have to consider one source at a time as per our theorem. Let us consider current source alone first. Now first priority is given to the our mother. Okay. So in this case 6 amperes applying, and whereas the 30 volts simply shorted. So there is no internal resistance is given. Now once you can observe here, once it is shorted, what will happen? This 6 ohms resistor also becomes the 0, because here what you are observing that here high resistance is connected. Now I shorted this one. What is the resultant value? That becomes the 0. Now similarly here we connected the shorted, that what is the value here becomes to the 0. Then what is the circuit? Now this and shorted, that is the here we are going to get the 5 ohms. Okay, now shorted. Now here 3 ohms is connected and you connected the one current source directly. This is simple circuit. Now what you are observe, this and this is connected in parallel. Now you know the current here. You are going to find that what is the current here. So you know the current division method. You are going to calculate the what is the current here. Simple. Okay. So then find the value. Replace the value shorted as shown in the figure, and 6 ohm resistor is parallel to the short value, and this becomes the circuit. Okay. Now what is the value? 6 amperes is current here. I want to know what is the current here. Now as per division, so total current here 5 ohm resistors, I 5 ohm resistor is equal to, okay, what is the total current? 6 amperes into what is the opposite resistance? 3 ohms divided by, so 5 ohms plus 3 ohms. This is the current. Okay, that is equal to 6 into 3 by 5 plus 3. So we are going to get the current. Okay, 8, that is equal to 6 into 3 by 8. Okay, 2 3s are 2 4s are. Okay, so that 9 by 4 amps is flowing in this current, 9 by 4 ampere flowing current in the circuit, if only mummy is connected in the circuit. Now do it. Now here what will happen? So the current is flowing in the circuit is the, that is equal to 2.25 currents, we got it. This is the current. This current is flowing is a 2.25 amperes. This is a current division method. Okay. Now with help of the 6, here 6 amperes coming, in that 6 amperes only 2.2 amperes is flowing here, remaining current is flowing here. What is the current here? 6 amps minus 2.25 current, we are going to the current through this one, but it is not asked. We are going to find the only this current. Don't waste your time. Okay. Now next, now consider the voltage source. Now we consider the father alone. Replace the voltage source here. What you have calculated? Now replace the current source. Now mother kept outside for a moment. You keep it outside. So current source always open. Okay, it's open it. That what is the circuit? So you are going to get that voltage simple circuit plus minus, and here is a 6 ohms connected, here is a 5 ohms yourself, and now 3 ohms is connected because this is a open circuit. Okay. Now what will happen? Here 5 ohms and 3 ohms connected in series, and here 6 ohms connected. Now what is the value we are going to get? Is this is the one, and now we are going to this one. Okay. So 5 into 3 plus 8, this resistance. Now we are connected to the 6. This and this is parallel. Now we are going to get that value. So what is the value we are going to get? Nearly 3.43 amperes. We are going to 3.43 resistance. Okay. Now that is a resistance seen by the battery is equal to 3.43. So let us do it. So after know the resistance, we know the what is the 30 volts. Okay. Now voltage is the 30, resistance is equal to 3.43. Then we are going to find that the current. What is the current? Yearly we are going to get that the current is equal to 8.75 amperes is a current. From this circuit we are going to get, so 8.75 amperes. We know that value. Now I want to know that what is the current in the circuit. Simply, so here I know that what is the current here, that is equal to 8.75 amperes. So now I want to know that what is the current in this one. Same method. So here is the one circuit, this is the total current. I want to this current, so division current. So here total current is equal to 8.75 into opposite 6 ohms divided by, this is a 6 plus 8. We are going to get the current. Okay, that current may be nearly 3.75 amperes. We are going to 3.75 amperes. We are going to get current in the 5 ohms resistor. Now in this case we know the 3.75 currents, we got it previously with the help of our mother. So we have got it, how much current? That is called 2.25. Okay, yeah, this is a 3.75, previously 2.25 amperes we got it. Okay, but what will happen? The direction is reverse. So simply subtract it. Then we are going to get the resultant current. Okay, so that is the current we are going to get it. That is called 1.5 amperes current in the required 5 ohm resistors. Dear students, simple problems. Okay, you can see here. Now in this case what we are going to do? So replace the current source with its internal resistance. So here the infinity or open circuit due to the current source. Resistance seen by the battery is equal to 6 parallel with the 3 plus 5 here. So here you are going to, this is a series, now this is connected in parallel. So we are going to get the answer, that is equal to 3.43 ohms. Now total resistance we got it, total voltage we got it, 30 volts is given. Then we are going to calculate the current is equal to 30 by 3.43 and we are going to the 8.75 amperes flowing from the source 30 volts towards the circuit. Now applying the current division rule, current through the 5 ohm resistor is equal to total current into opposite 6 ohms divided by the total resistance. Then we are going to 3.75 amperes, we know that the current is flowing in 5 ohm resistor. Now superimposing of the results from current source and voltage source with directions. Now you can see the 5 ohm. So the current which is coming towards with the help of the 6 amperes current source is a 2.25 amperes from right to left. With the help of the 30 volts voltage source, the current is flowing from 3.75 from left to right. Both are opposite directions. Now resultant current and hence the net current difference of two values, that is equal to 3.75 minus 2.25. So we are going to get the 1.5 amperes. The current which is flowing from left to right is the correct answer. So this is asked the resultant values. Okay, so this is the final results. I think you have followed this problem. Now let us summarize application of superposition theorem. So what we are seen, please note that while superimposing the results, what we have seen, what we have to see, so we have to consider the direction of the currents in a particular element, whether it's going from left to right, left to right, left to right, right to left, or bottom to top, top to bottom direction. Okay, so whatever you are assumed, it should be consistent while doing the total problem. Okay, if the currents due to the all sources are acting in same direction, we can simply add it. If they are opposite to each other, we have to subtract. The same rule applies to the voltages acting across the resistors also. Now summarize what we have seen in this class. So in this class we have learnt about what is the superposition theorem statement. What is a statement? In any linear bilateral network having two or more voltage sources, the current through any branch is the algebraic sum of the currents produced by each source acting alone at a time when all other sources are replaced by their internal resistances. That is a definitional statement. The explanation steps, 8 steps were known or applied to problems. Then applications. So application point of view, wherever we are going to get the complicated circuits, then those are having the more sources, whether the current sources and the voltage sources, then we are simplified with the help of our superposition theorems. Easy to find the value at any element, given element. Okay, so this is a one example. Dear friends, if possible, you do the one. I am going to give the one homework for you. What is that one? So here one is one circuit is given here. Just you do practice it. Okay, the 3 ohms is given, 6 ohms is given. Okay, so later we can do. So explain the superposition theorem and application of superposition theorem. So we have learned in this class. So do the remaining problems also. So now The time is already 1:20. Then do the remaining problems. If you have any doubts, please clarify these doubts in next class. Thank you for listening.